Okay, one last concept here, the nth roots of unity. That just means that the nth roots of unity are the solutions of z to the nth power equal to 1. Okay, so it's just saying let c be 1 and solve z to the nth power equals 1. Okay, so let's look at an example here. Find the 3 cube roots of unity. Find the 3 cube roots of unity and display them on an Argand diagram. If w is the root with the smallest positive argument, show that the roots are 1, w, and w squared, and that the sum of those, 1 plus w squared, is equal to 0. Okay, so this part looks pretty complicated here, right? It doesn't make a whole lot of sense right now, but let's try the first part and see if we can make sense of this second part, okay? All right, so let's look at number 3 here. Okay, so we're going to solve this the same way that we've been doing it. So we're going to solve this equation, and we're going to use the nth roots method again, since factorization would not work very well here. Okay, it'd be hard to find the cube root of z, z cubed minus 1. It'd be kind of hard to factorize that. So what we do is we're going to do z cubed equal, now 1 is just over here, right? So it's going to be cis 0, 1 cis 0, which would be really cis of 0 plus 2 pi k, right? And 2 pi k, obviously when k is an integer, 2 pi k here, this 0 would disappear, so we just say this is going to be cis of 2 pi k. Okay, now let's take the cube root of both sides, so we end up with z equals, if I do this, okay, if I raise both sides to the 1/3 power, we would end up with cis, the 1 would just be 1, and we would have 2 pi over 3 times k, okay, where k is an integer. So what values can we put in? Let's just put k equals 0, so we end up with z equals cis of 0. If I put 1 in, I get cis of 2 pi over 3. If I put 2 in, I get 4 pi over 3. So cis of 4 pi over 3. All right? Now, this is really just z equals 1, right? Okay, we already know that. This is z equals 1. What about 2/3? At 2/3, we would have this vector. That would be 1. That would be pi over 3. So that would really be a special triangle. So that would be, since that's 60, that'd be root 3 over 2, and that'd be 1/2, and that would be minus. So it would be minus 1/2 plus root 3 over 2i. And 4 pi over 3 would be down here, and that would be 1. And so it'd just be this same one. It'd be minus 1/2 minus root 3 over 2i. Okay? Now, so this is really kind of the first part here. We found the 3 roots. These are my 3 roots. And now we have to say, well, now we have to find the second part. So if w is the root with the smallest positive argument, which one has the smallest positive argument? Okay, so we're not looking at the component form anymore. We're looking at, or the Cartesian form. We're looking at the polar form. This one does not have an argument of that's positive, so it's got to be this one. So let's say w is equal to cis of 2 pi over 3. Okay, if this is the case, show that the roots are 1, w, and w squared. Okay, since I already have this one, let's find what w squared would be. Okay, w squared is, if I take this squared, it's going to be cis of 2 pi over 3 times 2, right? So that becomes cis of 4 pi over 3, and that confirms what we had before. Okay, so this is one of our roots, this is one of our roots, and 1 is also one of our roots. So we've shown that those are the roots, and now we need to show that if I add all of those roots up, I get 0. All right, so how do I do that? I could add these, but that wouldn't help me too much. So let's add the Cartesian ones. Okay, so let's see, let's move down 1, okay. So then we can say 1 plus w squared would be the same as, okay, 1 plus w was right here, minus 1 half plus root 3 over 2I, plus w squared would just be this, minus 1 half minus root 3 over 2I. And now if I add these, well, that's minus 1 half plus 1, that's 0. Okay, and if I add up the imaginary parts, I get this plus this, which is also 0, so that is just 0. Okay.